Hello and welcome to the Museum of the Rockies video tours for Tots. My name is Mr. Dylan, if I haven't met you. And you see a clue what we're learning about this week around here. There's the guy with flowers and dinosaurs that did that. Oh, what's that back by the T-Rex? Hang on, let me go grab it and take a look. Cool! It's my rocket toy. It's called the Saturn V, and we're going to talk a lot about Saturn V rocket and some others. We're talking about space missions today, so it'll be pretty fun. Oh wait a minute. There's something inside. One of the doors is open. What's inside my rocket? It's that. It's that silly little space monkey. What are you doing in there, space monkey? Well, we'll talk a little bit more about space monkeys and everything later too. But first, we have to talk a little bit about baseball. Baseball? Why do we have to talk about baseball if we're talking about space missions today? Well, it's because it has to do with gravity. And what's gravity? And what is gravity? Gravity is a force that large objects have that pulls things towards the large object. So a really big object like the Earth has got a lot of gravity, and it pulls you and me and everything to the Earth. Your head is small and it has just a little bit of gravity, but the Earth is big, really big, and it's got a lot of gravity. And the sun's even bigger, it's got even more gravity. So that is what gravity is. It's a force that just pulls things towards really large objects. So why baseball? Next time you're outside, try this. Take a baseball or a tennis ball or whatever ball you have and give it a little toss. What happens? Well, it falls on the ground. Well, obviously, I think we knew that was going to happen, Mr. Dillon. But what if you give it a big throw? What happens? Well, it flies a little ways, and then gravity pulls it back down to the Earth. What if you gave it a really big throw? Well, it'll fly a little farther, and then it'll land on the ground. What if you took that baseball and put it in a cannon? Well, that's going to go a long ways and then before it falls back down. And a bigger cannon, you can launch it farther and farther before it falls down. But watch this. If you could build a big enough cannon and shoot that baseball really, really, really fast, that baseball, when it fell, it would fall, but it would miss the Earth. And if it misses the Earth because you shot it so far, it'll start going around the Earth. And when a little object goes around a big object, because of gravity, that's called an orbit. So that's pretty cool. So our super fast baseball can orbit the Earth, and the moon orbits the Earth because of gravity, and the Earth and the other planets orbit the sun because of gravity, and the sun orbits the supermassive black hole at the center of our galaxy because of gravity. So that's what gravity's doing. So we could use a giant baseball cannon to launch into space, but rockets have really become the best way to get into space. So let's look a little bit about what were the first rockets. It's kind of interesting. The very first rockets were made about 1,000 years ago in a country called China, and they actually called them fire arrows, which is a pretty cool name, an arrow that uses fire to launch. So they used an explosive powder called gunpowder to propel the arrow. And fireworks today are running pretty much on the same basic idea, where you have some gunpowder that forces it up into the air. And in a rocket engine, with whatever you're burning, whether it's gunpowder or a modern rocket fuel of some kind, it has to have a nozzle, which is a little hole. And the gunpowder on that guy's kitchen, because it's just in a heap, it just fires off, whoosh, and it's not directed anywhere, so there's no real force. But if you take the same powder and make all that smoke and fire go through a nozzle, a little hole, it creates a force and it pushes the rocket and away it goes. And a really big rocket will have a nozzle with a little hole and then a big bell-shaped part that's part of the nozzle. And that just helps make bigger rockets more efficient. Rockets and fireworks and things like that have been around for a very long time. And about 150 years ago, 200 years ago, people started thinking and coming up with some really cool ideas like, well, what if we could use rockets to travel to the space or to the moon? And there's a couple of really popular books written about them. One of the very first movies ever made was called A Trip to the Moon. And so that's pretty cool. And they use a giant cannon to launch to the moon, but the rockets at that time were much too dangerous to really try to ride. Then the next rocket I want to talk to you about was invented about 90 years ago or so. And so this is a man named Robert Goddard, and he was a scientist and an engineer, and he was working with some really big rockets, big solid fuel ones, and he thought, it'd be a really good idea if you get this rocket to start and stop. Or maybe only use a little bit of fuel at a time, and if you only use a little bit of fuel at a time, you actually burn for a longer time, and maybe you can even go higher. It's going to be useful sometimes to be able to go faster or slower with a rocket. So he figured liquid fuel would be the way to go. You can pump more liquid fuel to go faster or less if you want to go slower. And so he built this rocket, and he called it Nell. And he actually used gasoline in his liquid-fueled rocket. And gasoline, just the same gasoline that you put in the car. Kind of the same idea. If you want to go faster in the car, you push the gas pedal, it puts more gas into the engine, makes your car go faster. And if you want to slow down, you take your foot off the gas pedal, and not as much fuel goes into the engine, so your car slows down. So I thought that was a pretty good idea with a rocket, too. So it's pretty small compared to the big gunpowder rockets he was using. And it's a little backwards. The fuel is down there at the bottom. And then it's got fuel lines going up. And the nozzle's actually up at the top. So it's a little bit backwards from what we think of rockets today. And even from the rockets that he was working with. But he tried it that way first. So he kept building rockets and making them better and better. And he also figured out how you can steer a rocket as it's flying through the air too. So that's really important too. And the next rocket I want to talk about was the first rocket to make it all the way up into space. And it wasn't big enough to go into orbit yet, like our baseball cannon, but it could go up into space and then fall right back down. And it was called the V2 rocket. And you know what? It was actually made by some bad guys that put a bomb on that rocket. And that's pretty bad and that's pretty scary. But then we beat the bad guys, and we took their rockets. They couldn't send bombs on rockets anymore. And that's good. And we could experiment around with the rockets that we took from the bad guys. So a few years after that rocket, another country called the Soviet Union made the first satellite that you could launch into space and actually send it into an orbit. And the satellite was called Sputnik. And so that's pretty cool. And it was beaming out a radio signal that sounds like this. And boy, are we scared of this Sputnik satellite in America. Was it another bomb like on the V2? That would be scary. Was it spying on us and seeing what we were doing? And that sound on the radio. Was it a secret spy message to secret spies? What was it? Well, it turns out it was just a simple radio and a battery in the sphere. So the secret message all along was just beep, beep, beep. That's all the secret message of Sputnik was. It was a pretty simple satellite. And America sent its first satellite into space pretty soon after. It's called Explorer 1. And it had a lot more science machines and detectors on it, not just a simple radio and battery. And the different sounds you can hear on its radio are just different things being detected. And those are the first two satellites, and today there's a lot of satellites. And so we've got TV and radio satellites, so we can beam TV up to the satellite and then back down to other places on the Earth. That's a pretty cool idea. We've got weather satellites so that we can predict the weather and see what storms are coming. That's a pretty good idea too. We've got GPS satellites, which can tell you exactly where you are on the Earth, which is a really good idea in case you get lost. And we do have spy satellites now, like a giant camera in space looking down on the Earth, so we can see what the bad guys are doing and make sure they're not going to do it. And we also have science satellites at the Hubble Space Telescope. So instead of looking down at the Earth, it's looking out into space. And the Hubble is pretty cool too. And there's a new space telescope called the James Webb Space Telescope that's getting built too. And there's also these little guys called cube satellites now. It's gotten so cheap to build and send up satellites that lots of scientists use satellites for a lot of different projects now. There's thousands and thousands and thousands of them, but Sputnik was the first. So satellites are really cool too, but the main goal is to get a person into space and then a person on the moon. So both the Soviet Union and the Americans started trying to get people into space and then onto the moon. And there's kind of a race between the two countries called the space race. But it wasn't like two people running. It was just a race between the countries to see who could do the next space mission first. So they wanted to hurry and try to get the other one, but on the other hand, rockets are really dangerous. And they had a really bad habit of crashing and exploding sometimes. So we want to really be careful. You know, we didn't even know if people could even survive in space in weightlessness. It could be dangerous just to be up there. It's such a weird place if you're in weightlessness. So that's where my space monkey comes in. Because engineers wanted to make sure that it was safe to just be in space, in a spaceship, before sending people up. So first were some fruit flies. Scientists love experimenting on fruit flies. And then some mice went up into space. And then some little monkeys. And then there were even some space dogs too. So the Soviet Union then launched the first animal into orbit, a dog called Laika. And then America launched Ham the space chimpanzee. And Ham had to pull some levers and push some buttons to prove that people could pull levers and push buttons in space. Because if you could get in space and you could live in space, but if you couldn't do anything in space, I don't think you're going to be able to get to the moon really. So thanks to Ham the space chimp for proving that we could do that. And after he got back from Earth, he got to live in the National Zoo until he died of old age. And then he got buried at the National Space Hall of Fame. So thanks to Ham the space chimp and Laika the space dog and all the other animals. So with all the animal tests out of the way, then we're ready for launching people into space. We got the rockets figured out, parachutes figured out, people can actually live and work in space. And the first person in space was Yuri Gagarin from the Soviet Union on a Vostok rocket. And then it was a race to see who could get to the moon first. So then the first American people in space went on the Mercury rocket, which is just a really small rocket and a really little capsule up at the top. And it's pretty much just big enough for one person. It's very small. It's essentially just one chair and all the switches. And then the next program was called the Gemini program, and its purpose was at getting better at flying in space. So it had two people at the top of a bigger rocket, and that is just enough to get into space, into orbit. Not enough to go to the moon or anything, but enough to get into space. And flying in space is pretty tricky since you're actually falling around the Earth, so they really had to practice. They did the first rendezvous where two ships would meet up, and the first docking where they would come together. They actually did the first spacewalk too, where the astronauts would put on their spacesuits and open the door and go outside, which sounds really pretty cool, but kind of scary too. I'd be scared. And the next was the Apollo program, and its whole purpose was to go to the moon. But the Saturn V rocket is the rocket that Americans built to get to the moon. So let's take a look at it. And Saturn V is a really cool rocket, and I want to show you all the different parts because it comes in different parts. It's too heavy to go all the way to the moon all together. So the first part's got 5 really huge engines, and when all the fuel is burned up out of that, it breaks off and that falls back down to Earth. And then the next stage will be shooting off. It's got 5 pretty good sized engines also, still burning. That'll get you right into space. And at the very top is the escape tower, and the capsule's up there too. And the escape towers, if something happens and astronauts need to escape, they can. But most of the time, it just launches off at some point. I got us into space, so now to get into orbit, we've got the next stage. And it's just one rocket engine, space, and then launch off towards the moon. And at a certain point after you're on your way to the moon, the astronauts will fly out, turn it around, hook up to the moon lander, and pull that out. And then they're on the way to the moon. And that stage just winds up flying off past the moon. It just doesn't go anywhere. And then, so there's the two modules together flying off towards the moon. You've got the command module and the service module, and then the lunar lander part. Just got the computers and oxygen and stuff in there, and the astronauts just live right in the middle too. So once you get to the moon, they'll separate. Two astronauts go into the lunar lander, and it lands on the moon. And then when they're done and ready to come back up, it pops back up. It doesn't take much for it to get off the surface of the moon, not like the Earth. And then it meets back up with a command module, and you fly back to the Earth. And then as you get closer to the Earth, you'll eject the other two parts, and the only thing that's left is a capsule. It comes burning through the atmosphere, and it opens the parachutes, and it'll land in the ocean. And then the astronauts get rescued by the Navy, by some Navy ships. So the first people landed on the moon about 50 years ago, and about 40 years ago came up with a new spaceship idea, and it's called the Space Shuttle. And the big idea with the Space Shuttle is instead of having each piece be broken and you can't use it again, what if we could reuse different pieces of the spaceship? And it looks kind of like an airplane because that part flies back down to Earth, kind of like an airplane. So here's the different pieces. We've got the solid rocket boosters. The orange part is the fuel tank. And then the rocket engines are on the shuttle itself. So the fuel tank is on the outside, and the fuel lines go into the space shuttle and down to the rocket engines. It's kind of a cool idea. And inside the orbiter, inside the space shuttle, the back doors can open up and astronauts can carry satellites or space laboratories, or they can fix the space telescope or different things too. So it's a pretty good idea. The coolest thing that the space shuttle did was help build the International Space Station. And that's a really good idea too. And the idea was to work with 5 different countries, with astronauts from 19 different countries, to build a permanent space station and laboratory in orbit around the Earth. And it was built one piece at a time. Each piece of the space station got launched up with a space shuttle or with a Russian rocket. And then the astronauts attached it all together. And it took over 150 launches to build the thing. But astronauts started living on it right away when it was small and doing science. And we could even add more pieces now if we wanted to. It's a really cool system. I think it's going to be around for a while. And there's still astronauts in there living in there today and doing science and everything. They put up all kinds of cool videos about what it's like to live in a space station. I'd really like to live in a space station. I think it'd be really fun. And I just wanted to mention the new space mission we're coming up with, and it's called the Space Launch System Rocket, which is really big, and a new space capsule called the Orion capsule. I think it can hold up to, I can hold 4 or 5 astronauts, so it's a little bit bigger. And there's currently a plan to send an unmanned ship back to the moon next summer, which would be really cool. And then another mission to orbit the moon in 2023, and then maybe land back on the moon again and start building moon bases. And they want to build a moon space station too. So that's a really cool idea, and that's supposed to happen in like the next 10 years. That should be really cool. Craft this week comes in 2 parts, and the first part is building a rocket, a straw rocket. So you need a straw, you need the rocket template, some colors if you want to, and some tubes and some scissors. So what we'll do is we'll cut out the rocket. And then what you got to do is you got to wrap that rocket around your straw and tape it. And that can be a little tricky. And on the top, you gotta fold it a couple times to seal it up at the top there. So now you've got a straw rocket, and you can shoot it. And the second part of the project is to make an alien planet to launch your rocket to. So first we need a coffee filter and color like an alien planet. We don't know what colors alien planets are, so it could be anything. Take a piece of black construction paper if you have it, or whatever color paper. If you spray it with water, those colors ought to run and mix all together too, so that can be kind of fun. So, need to wait until that dries. And after it dries, you can put on some star stickers if you have any star stickers. And that'll look pretty good. So the last thing to do is you've got your straw rocket. You can put your planet up on the wall and try to launch your straw rocket at your planet. Our story for today is 3, 2, 1, Blast Off by Prabha Yam and Sheila Pruitt. 12 dreamy constellations floating in space. A constellation is a group of stars that forms a pattern in the sky. Sometimes looks like a mythological character or an animal if you have a good imagination. Cygnus, Lacerda, Triangulum, Cepheus, the Little Dipper, Lynx, Draco, Hercules, the Big Dipper, Scutum, and Orion are the names of these constellations. 11 shiny satellites up in the sky. A satellite is an object that goes around a planet or a star. Earth has a natural satellite, the Moon. Artificial satellites are launched into space for communications, astronomy, and weather studies. 10 busy engineers working on a rocket. Mechanical engineers, electrical engineers, and electronics engineers work together to assemble a rocket. 9 expert scientists calculating the orbit. Scientists figure out what the path the satellite will take when it's in space. This path is called an orbit. 8 stable planets going around the Sun. 4 rocky inner planets, Mercury, Venus, Earth, Mars, and 4 gassy outer planets, Jupiter, Saturn, Uranus, and Neptune, make up the 8 major planets of our solar system. Pluto used to be the 9th planet, but in 2006, the International Astronomical Union decided Pluto was a dwarf planet. 7 icy comets passing through. Comets are large chunks of ice, rock, and gas. They orbit the sun but are usually far from Earth. As they pass, they leave a trail that looks like a tail. Some famous comets are Hale-Bopp, Halley's Comet, Hyakutake, and Shoemaker-Levy. 6 curious people looking through telescopes. Telescopes help us see objects that are far, far away, like the comets, stars, planets, and moons. 5 small dwarf planets hanging around. Dwarf planets are like planets, but they are much smaller, and they don't yet have a clear path around the sun. This means objects like asteroids and comets litter their path. Pluto, Ceres, Eris, Makemake, and Haumea make up the 5 main dwarf planets of our solar system. 4 careful workers fueling the rocket. Just like cars need gasoline to run, rockets need fuel to take off and do their job. Rockets can use both liquid fuel and solid fuel. 3 skilled astronauts in their spacesuits. Spacesuits protect astronauts in space. Suits have oxygen supplies for astronauts to breathe and also water to drink. They prevent astronauts from getting too hot or too cold and keep them safe from space dust. 2 eager kids at the Mission Control Center. Mission Control Center is a room where team leaders get together and make sure the launch goes smoothly and everything works as designed until the mission is complete. One roaring rocket ready to soar. A rocket is a self-propelled vehicle that can shoot into space. It is used to launch man-made satellites into space. Blast off. India created a world record in 2017 when it launched 104 satellites from a single rocket. Scientists at the Indian Space Research Organization launched the rocket from the Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. The end. So that's all we have time for video tours for Tots this week. I hope you had fun learning about all the different space missions with space animals and early rockets and the first people landed and robots and everything. So, I hope that was fun. And until next time, we'll see you later. Bye.